conductivity is a key property of thermal insulation materials, often denoted by the letter K or the Greek letter lambda. It gives a measure of how easily heat passes through the material and is expressed in units of watts per meter Kelvin. This unit tells us how much heat energy flows through 1 meter thickness of the material for every 1 degree temperature difference across it. Heat naturally flows from warmer to cooler areas, and this heat transfer is called heat flux. The amount of energy transferred per unit area per unit time. Therefore, the greater the heat flux for a given temperature difference and a given thickness of the material, the higher the material's thermal conductivity. One of the ways we can measure thermal conductivity is a heat flow meter. This device places the test material between two plates held at different temperatures. Heat flows from the hot plate through the material to the cool plate. This is an example of a steady state method of measuring thermal conductivity. This means the device ensures a steady state temperature gradient between the two plates before a measurement is taken. The thickness of the material is important to consider here. A thicker material will generally reduce the rate of heat transfer. Before I make a measurement, the heat flow meter can either measure the sample thickness directly or I can enter this manually. Sensors in the device measure the temperature of each plate and the heat flux through the material. Thermal conductivity can then be calculated using Fourier's law of heat conduction. This means that the thermal conductivity is given by the heat flux through the material times the thickness of the material divided by the temperature difference across the material. Materials with lower thermal conductivity are better insulation materials because they transfer less heat. A U value is a related concept, but this applies to an entire building component, like windows or walls, and account for all layers, construction details, and thermal bridges. Understanding thermal conductivity helps us select better insulation materials and improve energy efficiency.